My name is Philip Antoniadis, and this is Supercharge MySQL Application Development with Generative AI and more. This is aimed at being a developer talk. I'm going to assume that all of you are familiar with MySQL and have at least enough understanding of generative AI that maybe you've talked to ChatGPT or something like that a couple of times. But beyond that, I hope the experts in the audience will bear with me if I explain some of the core concepts here. There are a lot of things that we have to get through. We've got a new release model. There's a lot of developer enhancements to MySQL. We've been innovating at a pretty good clip. So there's a lot of things that I'll go through over the course of the next 45 minutes. Starting with our new release model. We've been on a continuous innovation model for a while, and the advice that we got from a lot of our enterprise customers was to just slow down a little bit. So in the spirit of that, we've created a long-term release, the long-term support cycle for MySQL for all the versions, from the community version to the enterprise and up into MySQL Heatwave in the clouds. And the basic idea is that we will give you, similar to Oracle or Ubuntu, a version that will last without any changes beyond security fixes and bug fixes for 8 years. But in between that, for those people that are developing and who want to see all the new things that we're going to be coming out with, a lot of which I'll be talking about, we have these quarterly releases that are our innovation releases. The innovation releases will move fast and break things. They will have all the new features. They will have language changes. As you'll see, we're introducing a new data type. We're introducing a new programming language into the server. And those things will be available first in the innovation releases, and then when they're ready for 8 years of continual support and not breaking anything, they will get put into the LTS. Now, for years, developers in MySQL have used the MySQL command line client to be able to interact with the database. And a few years ago, we replaced that with the MySQL Shell. The Shell actually lets you interact with the database in not just SQL, but also JavaScript and Python. And it lets you, for on-premise, it lets you build HA clusters and set up replication topologies. In the cloud, it lets you connect to cloud-based hosts that don't have a public IP address. And it lets you have access to all the things that MySQL can do. And then recently, we integrated that with Visual Studio Code, which is the most popular developer IDE. So in all versions of MySQL, you can connect through a plugin with Visual Studio Code, and you're able to do things like have syntax highlighting for your SQL integrated with your regular code. You can connect to the database in one pane and be able to do your development in another. And you can use all the features of MySQL with integrated help. Now, this is available natively as a MySQL, as a Visual Studio enhancement, and as a Visual Studio plugin. So all you do is you just go to the marketplace, you install the plugin, and you're ready to go. You connect to the database wherever it is, whether it's on your laptop, in your server room, or in the cloud. And if it is in the cloud, you can integrate with Heatwave and get all the features that I'm going to be talking about today. And that's even if you're using, as I hope all of you are, a secure module where you don't have a public IP address for your Heatwave server. What a Visual Studio plugin can do is actually create a bastion host inside of the cloud so that you can be able to securely have an encrypted tunnel to your database without having to expose your database to the internet. And once you've done that, you have all the administrative tools. You can generate charts and see how your server's doing. As I said before, you can check the ability of your server to be upgraded, or find out, or create HA clusters, or enable high availability or replication on your servers. There's a lot of features. And the next thing that I'd like to talk about is that in addition to being able to use JavaScript to talk to MySQL, now you can create JavaScript stored programs inside of MySQL. We actually had to talk about this. If you've been here at Dev Live all day, we had part of our MySQL track was a session on this, and we'll have more on the Visual Studio things right after this. There's another session over in the hub. But JavaScript stored programs enable you to write in JavaScript in addition to SQL. The wonderful thing about them is that you can use them as anywhere you would use a native MySQL function. So you can put them in the select clause, the where clause, you can use them in DDL, all those things. So you have the ability to create these JavaScript programs that now can fully integrate with your SQL. And when you're creating them, you can use SQL in those JavaScript programs. So now you have all the benefits, whether you want to use declarative language or procedural language. You can have all of the libraries that are inside of JavaScript, as well as all the power of MySQL. And if you've ever had to debug an SQL stored procedure, it's not fun. So one of the things that developers like about the new JavaScript is that now you can write these procedures in a full IDE, in a full debugging platform. And the reason that you can do that is because we use the open source Graal VM. We have it embedded inside of Heatwave as well as the enterprise server if you're using MySQL in your data center. Graal is also made by Oracle. It is it is a subset of the Java JVM, but it is also somewhat language agnostic. So right now we only support JavaScript, but Graal has the capability to support several other languages, including Python and Java, that you may see from us someday. So now I'd like to talk about Heatwave Lakehouse. Heatwave is the term that we have for the full managed service of MySQL. And that means Heatwave is available on OCI as well as in AWS and Azure. It is a full managed service in the sense that we take care of all the upgrades, security patches, all those things for you. And in addition to that, Heatwave is the familiar MySQL transactional engine, but then it has the ability to spin up in-memory columnar nodes that enable you to have up to ½ petabyte of analytic capabilities in addition to what's in your MySQL database. Now, in addition to that, we've also added on a machine learning engine to Heatwave, which I'll be talking about soon. And Heatwave has the ability to read from object storage in whatever public cloud it happens to reside in, so that you can actually be able to have structured, semi-structured, and unstructured data, and be able to pull those things in and use them in different ways with the Heatwave engine. So when I say that it's fast for analytics, I mean that we think it's the fastest analytic database that is available in the cloud. This is the results of a ½ petabyte of data using an industry standard TPCH benchmark up in our cloud. And we've done this, we made comparable sized databases of all these other types to be able to have a fair comparison, but you can also do your own comparison because we've made all this available on GitHub. So, as I said, in addition to being an analytic database, you can load JSON, Parquet, CSV, and Avro files directly out of object storage. The benefit of this is that if you have a lot of database backups, if you have log files, if you have old files of various kinds of structured data, you can leave these things in the cheapest and most durable form of storage on the internet, which is object storage. And when you're ready to use them, you can read them up in real time into these hyper-fast in-memory clusters and start doing your queries. And then as soon as you no longer need this data to be available to you, you can spin down these queries, you can spin down Heatwave and save money. You don't have to have Heatwave always running all the time. And then, as I mentioned before, you have this Graal engine. So you have JavaScript available. So once you've loaded this file in, everything that's in Heatwave can talk to everything else. So you can use the JavaScript engine to be able to talk to the files that you've loaded out of object storage. And you can use all that to mingle with your MySQL data that you have loaded into Heatwave or that you've replicated up from your on-premise databases. And you have full access to all your data to do whatever you need to do. And then, of course, again, going back to performance, we like to talk about not just the speed at which we load or process data, but also the cost. Because if Heatwave is cheaper than the alternatives and it's faster, then the price performance winds up being impressive. And again, just talking about load times, you wind up having an extreme advantage over the competition in terms of your time to have your data ready to do insights. And then we also offer you insights on that system. You've probably seen, if you've been listening to the OCI presentations today, that OCI has done a lot to the metrics and observability for OCI in general. And for Heatwave, we've participated in that. So now you have a whole bunch of different ways of looking at your Heatwave data, as well as looking at how you're using your data and resources over time, and being able to manage and predict your resource usage and thus cost. Now that's in OCI. Then inside of Heatwave, we have another way of being able to manage your performance, and that is the machine learning engine. When we use it for our own uses, we call it Autopilot. And Autopilot is able to tell you if you should be using a larger Heatwave cluster to be doing your analytics, or if you should be using a different size shape for your MySQL database. It also now, in the newer versions, can tell you what kind of indexes you should be using. And after watching how you're using the database for a while, it can tell you that some of your indexes might just be costing you space and slowing down your inserts, whereas other indexes you might not have enough other indexes to be able to get the full speed out of your database that you want to. We've actually had customers that use MySQL in their data center do their dev test inside of Heatwave so that they can take advantage of Autopilot and be able to get those kinds of recommendations to know exactly how they should be using it best wherever they use MySQL. So that's how we use the machine learning engine inside of Heatwave, but we also make it available to our end users, to you. When we make it available to you, we call the same engine AutoML. And basically, AutoML, we like to say it democratizes machine learning, because machine learning is hard. You have to be able to get your data all in the right place. You have to be able to understand exactly how much of it you're going to use for training versus testing. You have to tune hyperparameters, and there's a number of use cases, and you have to understand how to use them. So if you're a MySQL engineer, I'll walk you through just some of the basics of how you would use machine learning inside of Heatwave. So basically, if you have, in all these different machine learning use cases, if you were to operate a small bank and you have a whole bunch of data on your customers, if a customer comes in and wants to know if they qualify for a loan or not, that's a classification problem. And you can have your Heatwave machine learning engine go over your data and predict that. Then once you've established that you're going to give them a loan, you need to decide how much that loan's going to be. That is a regression problem, and machine learning can do that as well. Now then, after that, you need to know how fast can they pay it back and what should their monthly payments be. And that's a forecasting problem, and Heatwave can give you that number as well. And then after you've got this happy customer who is paying back this loan, you'll want to know what other bank products they might be interested in based upon their background and usage. And that is a recommendation problem, and Heatwave is also good at that. So there's a lot that you can do just once you start understanding the machine learning process and how you can use the data that's already in Heatwave. And then you can add more data. So as I said, we have this lakehouse. Lakehouse is what we call this adding object storage to your database. And once you have your lakehouse data also coming into MySQL, then you can also use all of that to augment all these processes with your Parquet, Avro, and CSV files. And be able to have faster training. You don't have to, unlike other systems, you don't have to use a different machine learning system to integrate with your database. It's already in process. And we do that all through just these stored procedures. And the wonderful thing about them being stored procedures is that that means that anything that can connect to MySQL, so the same MySQL client that you might have been using in 1996, will still connect to MySQL, and as soon as you call MySQL train, it will build you a machine learning model, and then you will be able to score and explain exactly how that model works over your data. Now, the wonderful thing about these different procedures is that the biggest problem that we have with a lot of AI systems is that they're black boxes. But Heatwave AutoML actually allows you to say, for a given row, as well as for an entire table, how did you arrive at this thing? For when you said that this person qualified for this loan, what were the major factors that made them qualify for this loan? And you will get that back. You can also do what we call what-if analysis, where you can say, okay, well, what if they lived in a different neighborhood? What if they had a different annual salary? How would that change the outcome of this machine learning process? So it winds up being a very powerful tool for being able to get predictions out of your data. And to that, we're adding generative AI. So the basics of generative AI in Heatwave is that now you have the ability to do content generation and summarization. So essentially, if you have a whole lot of documents, if you have a whole bunch of PDFs or Word documents or PowerPoints that you have stored in object storage, you read them up into Heatwave, and you can ask Heatwave, what are the trends in all these documents? Or can you find something for me in these documents? And then you can use that for retrieval augmented generation. And the basics of RAG is that you are taking your data and using it to make the search results, to make the response that you get from a large language model both more accurate and more relevant because you're feeding it your data. You also have the advantage of not having to share your data in any long-term way with a new model or having to retrain a new model to understand your data. You're just providing it for a one-time response. And of course, the thing that people love about large language models is the natural language interaction. They like to be able to either ask a question using regular spoken English or be able to get a response back in something that you can hand right over to a customer because it is in a paragraph and not as a table of numbers. So it's important that I already mentioned the machine learning aspect of this because machine learning helps generative AI work a lot better. Essentially, once you've done this process of using machine learning to filter your results, to only get what's relevant or to make predictions, then you use generative AI to make those more meaningful to your customers or to give them, as I said, a prose response versus a set of numbers back. So let's look at some examples of how this would work. So the first one is a food delivery company. This is based on one of our customers in the real world. Basically, as I said, the recommendation system is one of the key use cases of machine learning. So once you have a whole bunch of order data from your customers, you will determine that, oh, this customer looks like they are a vegan and they really like dishes that have tofu in them. So now you've got that recommendation engine. You could just go through and do a search, find me things that have tofu that do not have all the things that vegans do not eat. Or you can just read through, you can have all the menus of all the restaurants that would deliver to them in object storage. You can read those up and then ask an AI engine, okay, what would you recommend out of these menus to somebody who is a vegan who prefers tofu? And then, of course, you get the added benefit that you will get this prose description of, hey, this is what you'd probably like, and we think that this one would be better than that one. So another more business-like thing is from one of our manufacturing customers. And today, they use AutoML to basically store their log files and do anomaly detection, which is basically the process of finding things that look out of place in a large collection of similar things. And log files are, of course, an ideal use case for that. So you can have gigabytes and hundreds of log files, read them all up into Heatwave, and then use machine learning to say, what are the anomalies that you find in here? Then, using a RAG process, you pass those anomalies in and you say, and you ask a generative AI thing, what is the problem in these logs? Give me a 2-sentence summary. And the generative AI, given the result set from the machine learning process, will say, the basic problem here is that you have one process that looks like it has gone crazy and it's using too much memory, and it's creating a whole bunch of sigterm signals. And then my final example is in the case of an employee assistant. So basically in a lot of financial and legal realms, you'll have dozens and dozens of contracts and other sorts of PDF files. You can keep these, as I said, most of the time you will not care too much to use all these, so you can just keep them in cheap and durable object storage. And then when you do need to ingest all these things, you read them into the vector store through a process that I'll explain shortly. And then you can ask an AI engine, hey, can you tell me, now that you've just given all these documents that I have available, can you tell me when was the first time I did business in Italy? Or when was the last time that this salesperson was involved in a contract? Or what is the trend in the business that we do in this financial sector? And you can wind up getting a nice summary of your data that in SQL would take you quite a lot of query writing. So all this is done with LLMs. And inside of OCI, Heatwave gives you a few different options as to how you're going to run those LLMs. Now, of course, as you've heard a few different times already, MySQL is an open source, at its heart, an open source product, and we are very fond of open source. And in the LLM world, that is no exception. So we love the Llama and Mistral open source LLM models, and those are available to run in process with Heatwave. Now, these are small models. Obviously, if you want something that is going to perform faster, or if you want a larger model that will obviously give you more, I'll say, more extensive results and abilities, then you can also move up to a larger open source model that you run on your own GPUs inside of the cloud, or you can use a service that you actually talk to through an API, such as Oracle's Cohere, or any of the ones that are available, through OpenAI and other companies over the internet. And then where you do that is also going to give you some different choices. You can obviously you can run it inside of OCI or any of the public clouds that Heatwave runs in, which includes AWS and Azure. You can also create your own and do that in a dedicated region as well as the public cloud, if that's how you use OCI. And then you can also use a hybrid, because as I said, the vector store is based on the vector data type, which is going to be a native data type, which is in all versions of MySQL, from the community version that runs on your laptop to the enterprise version in your data center or in the cloud, and of course, Heatwave. So given all these things, let's describe what the vector store actually is. So the vector store is a vector is a large multidimensional array that an LLM can use to turn a word or a short sentence into a series of numbers that is the representation of that term. Now, you can think about that as just the numeric representation of a concept, and I'll talk a little bit more about that. And then so we can store that in a native data type in newer versions of MySQL. And then those vectors can be searched to find out what other terms are similar to them in ways that are a lot more powerful than just doing a text search. In addition, Heatwave has the ability to create special indexes and special representations of vectors so that you can use them more efficiently for doing large-scale searches. Now, this also enables you, even without using LLMs or RAG or any of those things, you can now do semantic searches. So the basic idea is that if you have a vector, if you have vectorized a bunch of terms into your database, then when you do a search, a semantic search for cat, that will show you that it is close to the term lion, it is close to the term feline, it's even close to the term felix. But it's a lot farther from category or catheter or catatonic because it's just doing a meaning search. And that becomes extremely helpful when you start looking into being able to convert hundreds of databases and try and find things that are semantically similar among thousands of documents. Right now we do this with text, but going forward you'll also be able to use image and sound data to be able to find all kinds of similarity across any kind of document. And that's where the real power of this will come in. So the wonderful thing about this is that then you can use the vector database for obviously your structured data. If you want to take in just the text and blob fields from your structured data and be able to create vectors out of them. But the real power becomes with documents. So inside of Heatwave, you can use the vector storage to be able to read thousands of documents, PDFs, PowerPoints, any kind of Office document, as well as, of course, CSVs and other things like that. And then it will actually cut them up into pieces and create vectors out of all these pieces, and then save for you what the exact values and where they can be found are in a method that I'll show you in a couple of minutes. Okay. So the vector store, obviously the classic use for this is with RAG, is with retrieval augmented generation. The basic idea there is that if you have, in the case of my earlier example, the restaurant suggestions, then you have already read in all these menus. You've already vectorized all these menus and encoded the meanings of all the menus in PDF formats in whatever format you've gotten them from out of your object storage. Now, once you have that sentence of, hey, show me what we have that would be appropriate for somebody who is a vegetarian and likes tofu, then that vegetarian and tofu goes into the vector store and it finds out, oh, here's all the documents that have matching things in them. So rather than sending to an LLM all of your 10,000 menus, you just send them the 6 that actually the vector store said we're going to have the terms that you are looking for. And then, of course, that becomes an augmented prompt to which you get back a true response with just the dishes that you want. So this is the basic process of using the vector store. You bring in all your documents into the object store. They get parsed. They get chopped into pieces, as I said, which could be sentences, could be phrases, could be words, depending upon the size of the document. And then we create the embeddings. So as I said, Heatwave will have the engine inside it, not only the LLM engine that is able to create the natural language responses and create the and process the decision making that you wanted to, but also to be able to take these natural language snippets and create an embedding with vectors of just their meaning and where they are in this meaning space. And from that, you wind up getting insertions into the vector store. And essentially, it looks like this. So inside the vector store, you would have, here's the document, here's what we know about the document, and then here's the segment of it and the embedding. So for example, if I have already ingested all my PDFs into this document, into this vector store, then I will have, for each document, for each segment of the document, I will have that this word cat, there is something very close to the word cat, so it could be the word tiger, is on page 6 of this PDF in this location. And so you have the indexes in place to be able to get those exact matches and be able to rank them in a variety of different ways across the document. And then the vector store is also, because you're doing this, because you will tend to vectorize and embed thousands of documents, we are able to do this highly parallelized. So you can do this, you can scale this out across thousands of nodes very quickly and be able to have all of your documents processed in a matter of minutes instead of hours. So to summarize, Heatwave is everything that is in MySQL, everything that is in the open source MySQL, the enterprise MySQL, run as a managed service inside of OCI as well as AWS, and also Azure. And in addition to being this managed service database, it also has a machine learning engine that is capable of acting on all of your data as well as semi-structured data that you read in through object storage. And it has this Lakehouse functionality that you can read in structured data to be used in conjunction with data in the database, semi-structured data to be converted into structured data, and completely unstructured data that you are still able to use for all these processes involving machine learning and generative AI. So that is what I had to talk about today. And does anybody have any questions? Sure, yes. Yes, can you back up one slide, please? So as far as a vector, so the idea is that, as I said, if we take a term, so if I say soccer, and I turn that into a vector, obviously if we're just looking for words inside of a database, I won't be able to say soccer is similar to football, because those two words are totally different. However, in a vector space, they're right next to each other, because they're pretty much used interchangeably, at least in this country. And then if you say sports, well, sports is not the same as soccer and vector, but if you said, if you had said finance, that's a lot farther away. So basically, a vector is a way of putting this meaning into numbers. It's kind of like a score, yeah, but it's multidimensional, so it'll understand. It's not just that this word is always closer to this word, but these terms all exist in this different multidimensional space. Does anybody else have any questions about vector store or anything else? All right, well, I guess I finished a little bit early, but thank you very much.